Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data teams everywhere face the same problem. They're forcing ML models, streaming data, and real-time processing through orchestration tools built for simple ETL. The result? Inflexible infrastructure that can't adapt to different workloads. That's why Cash App and Cisco rely on Prefect. Cash App's fraud detection team got what they needed: flexible compute options, isolated environments for custom packages, and seamless data exchange between workflows. Each model runs on the right infrastructure, whether that's high-memory machines or distributed compute. Orchestration is the foundation that determines whether your data team ships or struggles. ETL, ML model training, AI engineering, streaming, Prefect runs it all from ingestion to activation in one platform. Whoop and 1Password also trust Prefect for their data operations. If these industry leaders use Prefect for critical workloads, see what it can do for you at dataengineeringpodcast.com/prefect. Are you tired of data migrations that drag on for months or even years? What if I told you there's a way to cut that timeline by up to a factor of 6 while guaranteeing accuracy? Datafold's Migration Agent is the only AI-powered solution that doesn't just translate your code. It validates every single data point to ensure perfect parity between your old and new systems. Whether you're moving from Oracle to Snowflake, migrating stored procedures to dbt, or handling complex multi-system migrations, they deliver production-ready code with a guaranteed timeline and fixed price. Stop burning budget on endless consulting hours. Visit dataengineeringpodcast.com/datafold to book a demo and see how they turn months-long migration nightmares into week-long success stories. Your host is Tobias Macy, and today I'm interviewing Ariel Pohoryles about data management investments that organizations are making to enable them to scale AI implementations. So, Ariel, can you start by introducing yourself?
Of course. Hey, hi Tobias. Nice to be here again. So my name is Ariel Pohoryles, as you mentioned. I'm with Boomi. I lead product marketing for the data management offering of the Boomi platform. Been a data engineer in the data space for more than 20 years now, and happy to speak about the data.
And do you remember how you first got started working in data?
Yeah, I actually learned data engineering at school and university. And it wasn't called data engineering back then. It was what's called information system engineering, but essentially the same idea, learning about databases and concepts and SQL and coding and whatnot. So I was always around the data. My first job out of school was being part of a data team in a large semiconductor company. I then moved on to be part of a data analytics vendor company. This is where I first found my love for combining my data experience with product marketing. I went on to manage a data consulting firm where I did all kind of data projects with different customers of different size, different industries. And then again, in the past 3 years, I've been back on the product marketing side for the data offerings of the Boomi platform.
And so we're here to talk about the recent survey that you and the rest of the Boomi team conducted about the current state of investments that various organizations are making in terms of the data that they need and the AI initiatives that they're trying to power with it. And I'm wondering if you can just start by giving a bit of the overview about what you were trying to achieve through the action of actually conducting this survey.
Yeah, absolutely. In product marketing, a lot of things that we try to do is create a lot of thought leadership content. And to me, the best way to create that content is really based on data. Not surprising, right? So running this type of surveys is kind of usually providing the best evidence and the best understanding of what's really happening in the market. Obviously, not just looking at our own customer base, but in general among the community. And of course, AI is top of mind for all of us. But I think specifically for the data engineering world, the impact of AI is not just around providing us more tools for productivity or efficiency gains, as we see for most other jobs. But in data engineering specifically, I think we see the impact on us data engineers being involved in also the motion of creating AI solutions and building those AI solutions. So want to better understand how is that going to affect the workloads of AI engineers? What does that mean? And specifically at Boomi, we're heavily investing in not only providing the foundation, one would need to leverage AI. So think about everything you need to integrate your data, to integrate your applications, to manage your APIs, MCP management now with AI kind of being consumed in different ways, but also actual agent management around being able to build and govern agents. And so with that in mind, we were really curious to see how data leaders are seeing the data work changing as they prepare to enable AI across the business.
And as far as the role of data engineers in this new era of generative AI and the high demand for data of varying shapes, I'm just wondering, before we dig too much into the details, what are some of the key takeaways that you found most significant, surprising, interesting, whatever adjective you want to apply to it?
One thing I should probably add just before I answer the surprising takeaway or the significant takeaways is that we did that research with 300 different data leaders working across 8 different markets. It was recently done, actually, just earlier in this year. And most of the respondents were in the US, the UK, a good representation out of Europe, Canada, Australia, New Zealand. And we chose 4 kind of popular industries: tech, financial services, retail, and all that. And of course, we came into that with assumptions in mind of some specific ideas that will probably hold true. And indeed, that was valid with a lot of the data points we've seen. But then there was definitely some surprising or significant takeaways. I think one of those was around the fact that many data leaders consider their organizations or themselves to be fairly mature around regular data monitoring and quality checks, but only 50% trust their data. And so that was quite surprising. And you have a maturity around data monitoring quality, but still you didn't achieve that level of maturity that that would give you, or that trust level that you would need. And especially that's more impactful in the age of AI, because AI can go in different directions. But even for standard analytics, if you only have 50% trust in your data, that's to me quite of a red flag, if you will, that indicative of the bigger challenges that we have here. And I think that's not new. And I mentioned I've been doing data for a lot of years now, and I think that's always something that we've been kind of fighting to a certain extent. Even though when I started my career, data engineering was much simpler, far fewer sources back then, and everything was on-prem. Refresh rates were smaller, data volumes were smaller, but still, managing data quality was always a challenge. And I think it's obviously just getting more and more complex. And now with AI, that's probably the biggest kind of a takeaway that we take out of this, that low trust in data. I think one other stat that we saw in the research that may explain a little bit of that was the low maturity of level of automation in data pipeline. And that's something we'll probably talk about a bit more later on, but maybe that's a reason to explain why there's still only 50% of organizations really trusting the data.
To the point of that lack of trust, I think it's possibly also just a matter of the level of attention that's being paid to it, where if you don't have any thought of adding data quality monitoring, you're just saying, oh, I've got lots of data, of course I trust it. But if you're actually doing that work of measuring the quality, measuring the reliability, then you might be a little bit more skeptical by nature and say, well, I have these numbers that say the data's good, but I'm not totally sure I believe it. So maybe it's that healthy dose of skepticism that is biasing some of those responses.
That is a very good point. I definitely agree with that.
And so, digging now into some of the survey results, I think one of the key takeaways is that a lot of the data leaders trust the data that they're using for their AI systems, but they don't necessarily trust the overall data quality. So, to your earlier point, and I'm wondering how that reflects some of the ways that those people, where maybe they have a higher degree of confidence in the data that they're using for AI, but low overall confidence, how we can reconcile those two. Like, where is the data for their AI systems coming from? Is it that they have two different answers, even though it's maybe relying on the same underlying sources? Or are they curating only their most trusted sources to feed into their AI systems, which gives them higher confidence in the actual usage of that particular area of data versus their overall impressions of data at the organizational level?
Yeah, I think you're definitely diving deeper into that key takeaway I mentioned with that paradox of 77% of leaders trusting data in their AI systems, but only 50% trusting data overall. And I think it's mainly suggesting that most AI systems are currently built on a very small static data set. I think you talked about kind of the golden data set, if you will. It really makes sense when it comes to feeding AI systems with unstructured document and specifically query data sets. But I think it also suggests there's a white space there. There's still work to be done when it comes to feeding our AI systems with continuous data feeds of both unstructured and structured data. And I think the other assumption that comes to mind is also that some AI systems are built directly on top of source application data sets instead of on top of centralized data systems such as data warehouses and lakehouses. So as a way to kind of make sure that we trust the system, we plug it directly into a certain application and only run the AI functionality on top of that source system. That obviously makes it a bit easier to make sure that data inside that system is accurate, but then that means that the AI solution is also a bit more narrow in scope. It's a bit more isolated than the rest of the universe of your data, and can probably reason and do less for you because it's created just on top of that small subset of data. If we look at the technical challenges that are kind of limiting data teams of going and deploying AI across all the data sets, I think most data engineers these days, to a certain extent, they got exposed to building RAG data pipelines. They understand how to feed certain AI systems, vector databases, and all of that. Now it's becoming almost like a standard data type within the databases they've been using so far. They don't have to go even to a dedicated vector database in many cases. But there's still some barriers when it comes to the setup. And I think the bigger problem we face when we look at how to scale AI systems usage of larger data sets as we want to make sure the data sets are trusted is that with AI system, what used to be good enough for an analytical system is not good enough for AI systems. So what I mean by that, I'll explain in other words, is that prior to AI, if we built an MVP that, let's say, was just a simple dashboard, okay, for the sake of the example, if we build a dashboard, even if the dashboard is 80% of what the users ask for, it's usually a great starting point. And with AI, delivering a solution that's only 80% of what the users ask for is actually providing or exposing us to a great risk, because AI can do so much reasoning on its own and provide very different outcomes than what we could expect, and the consequences of that could be quite scary. So I'll give an example of our own deployments. We've added into the Boomi data integration platform an AI assistant that helped our users to ask different questions about the way the platform works. And so we connected to our documentation site and to a few other wikis and data assets that we had to help essentially shape data responses that users would typically ask around how to operate the platform. For example, how to build a change data capture data pipeline, or how to orchestrate a certain process or whatnot. And what we saw is that many users were asking this type of questions, but we also had a great population of users asking pricing questions, which we obviously did not plan for. And this is where we saw the risk of the assistant not answering correctly, or providing information that may make it sound complex, or is not positioning the platform correctly. Of course, we were lucky in that case that the answers that were given were relatively fine, and we quickly mitigated as we saw it. But that kind of risk was really clear to us immediately, because that's not a scenario that we considered. But AI's ability to do its kind of own thinking really kind of pushes you to the point where you have to make sure that all the data you provide to the AI system is really trusted, and you have the right guardrails around it. So if I take it back to the technical challenges, I think we do expect and see it in research as well that the need to connect AI systems to more data sources is growing. But at the same time, data teams are already quite busy, and to make sure they can provide a wider data set and not just a small golden asset to a certain AI system, there's a lot of automation that will be required in the data pipeline, and move away from some of the manual process they've been doing so far to ensure data quality. That's going to be a big part in how we can make sure that we can scale that across larger data sets.
Another aspect of the source data that we're relying on for these AI systems is that for air quotes traditional analytical use cases, we've largely been dealing with structured data assets. We have a lot of tooling and experience working with those styles of sources, dealing with data warehouse architectures, figuring out how we build quality checks into our pipelines for mutating and populating those data warehouses and delivering them downstream. We have sophisticated lineage tracking. But as we bring data into these vector stores, as we're relying more on unstructured data assets, whether that's just free text or semi-structured JSON blobs from various sources, and maybe we're not doing all of the same transformations on those to be able to route them through our structured data pipelines, how does that complicate the level of trust and level of curation for being able to actually provide that information to the AI systems? And maybe what are some of the additional technologies or practices that we need to develop to be able to build some of those same type of data quality checks when we're dealing with n-dimensional vectors, where trying to actually visualize that makes your head explode?
Yeah, absolutely. And you're right. I think that's part of it. And it's almost too easy to kind of rely on AI, right? Like let's just feed AI with the unstructured data, and AI will figure it out. But it works nice on a pilot, but it doesn't work well in production. That's a problem. That's why I think most organizations are still stuck in pilot mode versus really productionizing their AI solutions. And so, to your point, what are the new types of data quality checks we can do? How can we actually go about ensuring the quality and doing that not just with human in the loops, which we all know we need. And I think a great part of it is applying a lot of the concept that we had around the way we monitor data quality at our ingestion layer and data storage layer, but do so at the AI solution layer. So we want to make sure that the AI responses are accurate and relevant, and we need to make sure that we have the visibility into not just the outputs that the AI system provided to the users, but also the workflow that the AI process went through as it produced that. So getting full access to the trace, have a good understanding of what's happening in each step of the process, the activity log. These are things that we invest in quite a bit actually in our own agent management system. And we provide users to begin with a lot of governance tools around different guardrails they can define or anomaly detection monitors that gave them full access to understand what is happening and then ensure quality accordingly. And I think that's why sometimes we see the speed of moving a solution from pilot to production really slowing down on the AI side because of kind of that uncertainty of what's going to be happening to us from an output perspective. And getting that visibility is really what helps us kind of quickly iterate and tune the models and the solutions to provide us the right certitude we need to be able to deploy that with minimal risk.
Another relevant and accompanying takeaway from the report is that in terms of actually determining the data quality and doing the validation work, a lot of organizations are still relying on manual processes for that review, which obviously isn't sustainable as even without the requirements of AI because of the influx of new data sources and the integration requirements across them. And I'm wondering how you're seeing organizations think about that bridge from I have these manual processes, how do I actually build enough consistency in them to turn them into an automated process? And maybe what are some of the ways that we can either bring existing large language models or fine-tune models to be able to learn some of those manual processes and patterns and automate them so that they can scale beyond just what a single or a team of humans can actually process and comprehend given the influx of new sources and new requirements.
Yeah, I mean, this was one of the most surprising stats for me. We saw that only 42% of organizations have automated a data pipeline. I've been working on modern data integration tools, and at least in the past 5 years. So I sometimes forget that not all organizations are at that point where their connectors are fully managed. And I know that still many organizations don't have automated CDC data pipelines for efficient incremental data extract. But still, I'm kind of, I guess, sometimes forgetful that there's a lot of kind of manual workflows there, or at least ETL and data pipelines that are still not automated from the point of view of detecting source API changes and updating for that, or handling schema drift, or even just automate incremental loads into a warehouse or lakehouse. And so that number was higher than I expected. And I think the main hurdle for organization is, as much as there's all those shiny LLMs and other options out there to speed up their migration, there's still a lot of legacy, especially with larger enterprises, legacy platforms out there. A lot of the code and the logic in those legacy platforms is hidden behind GUIs, graphical user interfaces that are very hard to understand. Sometimes someone built it over 10, 15 years, and just going into all the business logic behind it and understand what's happening there, moving that to just plain SQL that you can easily move around is a big task. And so I think the fear is real. Understand why the cost of migration is a concern for many organizations. And my advice to them is, they need to analyze the ROI of such migration, and they need to do so, but not just looking at the potential value of the new system, but also the time they spend today on maintaining those current platforms and the lost time they have when it comes to build new solutions. So I think in an ideal world, what those organizations should do to increase the data quality rather quickly is as always, kind of try to pick the high value use cases and start automating those with data integration processes. And then from there, hopefully they can start to see a clear path to planning a full migration out of that kind of legacy systems. But yeah, there's still a lot of those legacy systems around, and not easy to introduce LLMs on top of them as they stand. So you have to kind of find a way to modernize and then be able to leverage those options.
Composable data infrastructure is great until you spend all of your time gluing it back together. Bruin is an open source framework driven from the command line that makes integration a breeze. Write Python and SQL to handle the business logic, and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. Bruin allows you to build end-to-end data workflows using AI, has connectors for hundreds of platforms, and helps data teams deliver faster. Teams that use Bruin need less engineering effort to process data and benefit from a fully integrated data platform. Go to dataengineeringpodcast.com/Bruin today to get started. And for dbt Cloud customers, they'll give you a $1,000 credit to migrate to Bruin Cloud. I think given the introduction of the legacy systems conversation, it might also be interesting. I don't think we illuminated this at the beginning of the conversation, what the composition is of the survey respondents as far as the maybe geographies and scales of organization, because talking about legacy systems always makes me think enterprise, which is not a fair association. But I'm just wondering if you can maybe talk to some of the ways that you selected the respondents and some of the feedback that you got and what that distribution looks like in terms of what data you're pulling from.
I think I mentioned it quickly and when I talked about kind of the key takeaway that surprised me, but I'll just maybe go a little bit deeper. So we surveyed 300 respondents. They were all data leaders, either in the senior executive working in data analytics role, or someone that's extremely familiar with data management and AI strategies within the organization. And those data leaders, these are the ones that essentially provided the quantitative response to the survey. We also had a few interviews that went deeper to provide some additional qualitative answers. But all the stats I've been quoting so far, these are all from the quantitative numbers from those 300 data leaders. They come from the US, the UK, lots of other European countries. We had surveys from Canada, Australia, New Zealand. And this was done in top industries like tech, financial services, retail, manufacturing. These were the top 4 industries I think that the response came from. We collected the data back in April and May of 2025, processed our findings, and I think we published the results about a month and a half ago.
And digging a bit more into some of the specifics of the actual AI use cases, AI as a term has largely been co-opted to be synonymous with generative AI and large language models, but in its technical definition, it also encompasses other machine learning systems, the deep learning models that preceded the current generative systems. And I'm wondering how the respondents are generally thinking about AI given that context, and maybe some of the difference in as far as requirements when you're going from maybe a regression style machine learning model versus a deep learning model versus these transformer based architectures that are largely on the generative side.
I mean, I think the world as obviously greatly is now generally associating when you say AI with generative AI. That's where obviously most of the excitement and opportunity is around right now. And it's a good question you ask around how is that different than AI that was produced with ML models and regression or predictive analytics that we were able to produce using machine learning models. I was thinking about that just a few weeks ago as I was chatting with a friend, and I was going back to some of the project that I was running as with the data consultancy team I was managing, and thinking about some predictive models that we built using machine learning and how we train those models. And we always used to have a best practice of kind of setting up, which is not unique to my team. I think all teams that deploy machine learning models do typically is, you set up your kind of quality process or your validation process in the form of, I have my current champion models and I have candidate models. I'm always testing against it to see the results of those models and how well they perform. And then over time, I kind of promote the next candidate that performs better than my current champion to be the next running model. And I think that way of monitoring the quality of the machine learning output is much more similar to the way we would monitor the quality of a traditional data pipeline. But again, it's not the same way we would do so on top of generative AI because of the ability of generative AI to go into so many different directions, which is why I think we need to get that extra visibility of what's happening. And we can't just rely on ensuring data quality is high at the ingestion level or at the storage layer. Even if we do master data management processes, these are all things we have to do, especially because the black box of what's happening with AI output is so big. But we still need to add on top of it another layer of quality. And the other thing I'll say around that maybe ties back to the one of the earlier questions you asked me about, those small data sets that AI solutions are being built upon. And my assumption is that we see a lot of those AI solutions, generative AI solutions, being built on top of the source application systems, not a data warehouse or a lakehouse. And I think what that means for us from a data engineering perspective is that now we can no longer look at data quality only from the perspective of the data that we pulled into our own storage layer, but we also have to think about data quality back at the source system. And that's something that as data engineers, we often kind of didn't pick that fight and kind of let the business kind of manage that on their own. And we will kind of make sure data is accurate as far as we can control it once we ingest it with master data management solutions, whatnot. But I think what we need to think about now is, okay, AI solutions could be built directly on top of the source system. Let's make sure that all the efforts that we've done to make sure that our centralized data layer is accurate, or at least our integrated data processes are accurate, is also contributing and benefiting the source system. So we need to have that kind of bidirectional syncs that push data back into the application system as well.
That is also an interesting point where, because of the fact that that these generative models can be much more forgiving as far as the source data that they're working with, you maybe don't need to do as much preparation to get to a proof of concept as you would with building a BI dashboard. That might then encourage non-data teams to be the first movers in terms of actually implementing these AI solutions. And so there's the question of how much oversight does the data team, or how much visibility does the data team even have into what AI workloads are being used and how they're being used. And I'm wondering how that factors into some of the questions of data governance, and maybe some of the ways that the definition of governance needs to expand to incorporate these models, especially when they aren't necessarily ones that are built and deployed in-house.
Yeah, that's a great question. I love that question because, I think it's interesting. Data teams almost naturally kind of inherited the role of being the ones that would build AI solutions within the organization. But to your point, everybody can build an agent these days. Almost, it's lots of tools out there. It doesn't have to be Boomi. Lots of tools out there. Obviously, use Boomi if you're listening to this. But lots of tools out there are offering the ability to build agents very quickly, very easily, and can vibe code it. Right? You don't even need to be a data engineer to build those AI solutions. So I think kind of the shadow AT that we used to have as a challenge now is becoming a whole challenge around how do we manage this whole shadow AI agent kind of world. And I think we won't be able to really fully control or prevent all the users in the business to build their own agents. And essentially what this will represent for us is a new sprawl that we'll need to manage. If so far the sprawl for data teams was to manage different data sources and being able to connect to so many different systems, the business adopted because it's so easy to sign up to a new service that now contains important data that you need to bring in to run your business correctly. The same thing that would happen with agents. And we already hear top executives talking about the agent force augment a lot of the workers in the business. We're going to have thousands of agents running the business. And I think similar to how data teams kind of inherited naturally the role of building agents, at least from an organized kind of corporate perspective, we're going to inherit also that problem of managing the agents that are building the business, even if we were not the one building them. That is an area that we invest in a lot, not just how we can build agents accurately, but also how we can govern them, whether they were built in the Boomi platform or outside the Boomi platform, because we recognize that users will choose their own systems. And it's important for us to give the same level of visibility and governance around who's using the agents, what are the agents actioning, how can I disable agents, which agent is certified. All those things are important aspects of governing those agents. And we invest quite a bit in providing that visibility for data engineers because it will fall ultimately on them. The other team that it may fall on, I think in the future, is the application team. Back to the point of agents kind of being built, not necessarily on top of the centralized data warehouse, but maybe on top of the application layer itself. And I think what we'll probably see in the coming years is also a bit of a convergence between data teams and application integration teams kind of coming closer together. Up until now, they were both operating from very similar data sources. They both had to extract data from a NetSuite or from SAP or from other business systems they use. But the data team pulled that into a lakehouse or warehouse, and the application integration team pushed that into Salesforce or to another system. But I think now with AI agents, they're all going to start working together much closer. And the bridge is essentially going to be that the agent that helps activate the data and operationalize it, but with the right data quality that hopefully the data teams can help ensure.
Another piece of it, too, that factors into that question of governance is that going back to our existing set of tooling for these structured data sets and the lineage tracking that goes into them, we will also need to figure out, either by extending the tools that we have or adding new considerations or adopting the various protocols that are being thrown out there, how to automatically register these different AI workloads into some sort of catalog to be able to also get visibility into not just the cost management, but the data management. What are you feeding into it? How often is it being refreshed? How often is it being used, so that you can decide, okay, maybe this AI system is not worth the spend that I'm committing to it because nobody actually cares, or the usage that it's actually producing isn't having the desired effect. And so being able to factor that into a lot of the typical cycles and life cycle management of the data assets that we build, where we'll build an asset thinking that it's going to be useful, but if it doesn't get used, maybe we can cull it and save on some of those storage costs. How do we extend that to also include these different AI workloads into that overall ecosystem?
Yeah, 100%. I can't agree more. I think metadata is kind of it's kind of its best days these days. It's probably one of the best assets data teams can use to ensure higher data quality, and not just higher data quality, but also feed better context for AI agents. So the AI agent output is more tuned and in line with what the objectives are. And to your point, kind of expanding that metadata, expanding the catalog with agents usage is essentially the next level to kind of manage that agent sprawl. It's going to have some different characteristics than what we typically see in data catalogs. It's not just around data assets usage. It's also going to be around what are those agents are doing, which is not a level that we typically capture today in when we think about data catalog of our dashboard inventory and the tables inventory and whatnot that we have in our different data storage layers. This is going to be a catalog that will also list what the agents are actually actioning on our behalf. That's going to be a critical component of it, but certainly sharing a lot of similar characteristics to what we do today with data catalogs.
And the other piece of the question of data governance, and to your point of a lot of these AI systems feeding off of application sources rather than a centralized data lake or data warehouse, is the fact that the whole reason that we built data warehouses is that all of those different application systems have a different view of the world, different opinions, different semantics, and we wanted to consolidate them and conform them to the overall organizational requirements and the organizational view of things. And so by bringing these AI systems back to the edge, we're fighting that same battle again, where we need to have agreed upon, well-defined semantics of what it is that we're actually talking about when we say customer, when we say purchase, etc. And how are you seeing, based on the results of this survey, organizations address that complexity of the need to move fast and get things into production, or at least into proof of concept, but also wanting to continue with that investment and having that shared understanding and shared semantics across the different agents that might be deployed across the various sectors of the organization?
Yeah, and I think that's exactly that challenge that we've kind of seen earlier on, that we talked about, that paradox between the high trust in the AI systems that were deployed so far, but the low trust in overall data in the organization, data quality in the organization. And I think that is exactly the way to bring that up, to close that gap as we think about more useful AI agentic solution that we can build, that can reason better, that can take into account not just the operational data of one system, but multiple systems, as if we were to look at a dashboard, but the agent does it himself and decides, okay, this is the best course of action going forward based on that intelligent insight that I received. I think this is where we would need to make sure that metadata layer that we talked about earlier is really serving us in the way that we can leverage it to feed our agents with the right context. And so that would be kind of the connecting tissue to make sure that we don't lose that investment in storing our data in the warehouses, lakehouses, in the way that can be managed, but also leveraging it effectively via agentic solution. By the way, I'm not sure that that means that we have to centralize everything in one place. And I think what we see in the past few years is that data warehouses, vendors also realize that they can't expect all the data to be stored in their own warehouse. And so what we started seeing a few years ago with external tables that interacting directly with data in S3 or other kind of bucket storage layers. And now warehouses kind of using formats like a iceberg and whatnot to manage table as well. I think warehouses are also realizing their role in kind of being able to govern all our different data assets and allow us to work with that unified experience, with the idea of being able to then eventually serve it effectively at scale for agentic solutions. So I think we're getting there. The key would be to make sure that metadata is fed across not just the warehouse, but also the agent that's kind of being able to leverage it.
And then to your point of having that federated data layer where maybe you have one place where you go to actually start your journey and start your work of working with the data, but you're able to actually access more than just what is in the, whether it's an appliance or something like Snowflake or what have you, the warehouse itself, you're able to also access some of the either more loosely structured or maybe not as refined data assets that live in maybe an iceberg table in S3. How do the additional stresses and additional needs for more and more data that these AI systems bring along impact the ways that we're thinking about the overall architectural patterns that we depend on to be able to produce and curate the data systems and signal the level of cleanliness and accuracy of that data to understand which ones to pull from, which ones to use either for fine tuning and training versus which ones to use for a retrieval that we're going to then surface and summarize and surface back up to a customer, et cetera.
Yeah, I think it's a challenge that again has started maybe even before AI demanded, partially because the cost of storage is cheap, or partially because there's new ways to manage data, as you mentioned, Iceberg and others kind of surface and really kind of expose all those options. And there was a big kind of motion around interoperability. How can we now run in a hybrid mode? And I think for some organizations, my advice is always trying to, maybe that's tying back to my consulting days, is trying to be very practical about it. It's very hard to define a data strategy and implement without clear business outcomes that you can measure relatively quickly around the data strategy. We're not longer at the days where we can define a 5-year data strategy and kind of execute on it slowly as we go. We need to see the payback fairly quickly. And so, if you're an organization that has a single data warehouse platform like Snowflake, as you mentioned, that serves all your needs, and great. I don't think you necessarily have to look at the way to branch out and leverage some of the newer options to just for the sake of saying we have that. It's actually maybe something that's make your life a bit more complex when you're trying to increase the data quality. On the other end, we know that many larger enterprises, they run in hybrid environments for a reason, and they need to have Snowflake and something else next to it, and Iceberg and whatnot. The dream would be to consolidate everything in Iceberg, for example, and have everything operate on top of that, but that's very hard to achieve. And so I think it will have to be a journey. And so going above the level of just a golden data set that we can serve for AI system, but maybe not necessarily opening up to all the to sit directly on top of our entire storage layer. And of course, again, doubling down on our metadata investment and finding that the catalog or even that master data management solution that's kind of getting like metadata a second life now. It's something that we kind of stopped talking about in the past few years, but now it's coming back again to fashion. Having a master data management layer that enables us to feed a bigger data set to our AI system, but still in a way that's governed and managed, so we can trust its quality. So we've seen a lot of customers kind of going back now to deploying their own master data management solution and making sure that they have at least a level of creation that they can fully trust before they push that onto AI systems.
And the other aspect of the level of consistency and assurance that you have in the underlying data also factors into the question of risk when you're taking these AI systems and putting them particularly in front of end users, but even just when they're internally used and their potential for inaccuracies or misrepresentation of the underlying data. And in that context, what are some of the biggest blind spots that you're seeing these data leaders encountering or trying to address to help them understand the ways that these inaccuracies can arise and the ways that they are either introduced by or compounded by their underlying data quality or data investments?
Yeah, I'm not sure how many podcasts you go by, how many episodes you go by without the garbage in, garbage out statement. I'm sure you hear it quite often. It's always been garbage in, garbage out. And to be honest, in most cases, even for AI, we're dealing with the same data quality challenges we faced in the past 20 years. The only difference now is that AI can scale or expose your data issues so much faster. I think the biggest blind spot to your question is that we don't really know how AI solutions will behave in every situation, because the human input can be very different than what we expect, and the AI output can be even more different. One of the data points that came out in the survey is that 13% of the data leaders that respond to the survey indicate that they already suffered from some kind of damage in their business from the AI system they deployed. And that's, assuming that most of those data leaders are not in production yet, right? Because we know that 80 to 90% are still piloting AI but not really deploying it at scale. And so to me, that's a big number. If 13% of data leaders already saw some damage, that is obviously a big risk here. And I think because we can't really control the outputs, and we do have a lot of blind spots, I think we really need to double down on what we can actually control. And so I think enriching our data correctly, removing duplicates. These are why I think I mentioned earlier that master data management kind of solutions are kind of getting a resurgence. It's because of those things. Like it's not necessarily easy to do proper deduplications and enrichment and then providing the right context and semantics without having those type of tools in place. And that's why I think we see more and more interest now in MDMs and metadata tools and so on, because that's becoming a critical part of how you make sure you can get that trusted data fed and reduce the blind spot that you have in your solution.
And so, given all of the information that you've gathered and the qualitative information from your interviews, as you're talking to data leaders who are figuring out where to invest their time and resources, and data engineers who are trying to figure out how to prepare for this massive influx and this new rate of change, what are some of the concrete steps that you're advising in terms of either where to spend their focus and research, or what are some of the technologies or tooling or best practices that they need to be building towards now so that they don't end up falling behind over the next 6 months, 12 months, 5 years?
Yeah. And before we get into tooling, if I go into tooling, that's probably the wrong answer. So before we get into that, I think the main tactics I would recommend to accelerate the strategy is really have that lens of the high value use cases. I think that we've seen a lot of AI solutions being deployed out there, a lot of investment in AI solutions, which are nice solutions, but not really affecting the bottom line. Think of different kind of tools that helps you summarize notes or chatbots or whatnot, but nothing really that kind of help you activate your data in a way that's really going to be impacting revenue or preventing churn or really improving your business in a way that's going to be significant. I think it will be much easier for data teams to justify any investments they make in a strategy to build a foundation for AI by focusing on the higher value use cases that can really then justify and provide proof for any work they do from a value perspective. So once we have that in place, and that's maybe a kind of a common recommendation, but often kind of forgotten, especially with kind of that FOMO that there is around AI and everything that's happening. There's a lot of excitement. We need to make sure we pick those right use cases to focus on. And the second one is really around automation. We talked about that earlier. And I think there are common benchmarks in the industry. I've seen that in multiple research being published about data engineers spending more than 50% of their time on data pipeline maintenance. I think that really has to be reduced. I think every repeated process they work on, especially on solve problems, things like data connectivity or managing incremental loads and doing deduplications of data and whatnot, wherever possible, these are the areas that I would automate the most, because this is what's going to A, improve our data quality, but B, also free up our data engineers to be able to tackle the higher problems and then really get to the point where they can build their AI solution. So I think the skills and knowledge for the most part are there. There's obviously more tooling that can always be added, but for the most part, kind of thinking about automating along the lines of the top value use cases, this is kind of the starting point for me.
And as you're working with teams who are trying to tackle this new set of challenges and try to stay up to date with the rapidly shifting ground on which they're trying to run, what are some of the most interesting or innovative or unexpected ways that you're seeing teams address the data needs for AI applications?
Yeah, I'm not sure it's an unexpected way, but I think most interesting way, at least in terms of the value those ways I could provide data teams, is obviously by using AI, especially to address the need to accelerate data needs for AI applications, use AI for AI. And really, AI can be used in every step of the process. If it's using just the example I just talked about around automating data pipelines, one of the interesting data points that came out of the survey was that 83% of companies expect to integrate more data sources for their AI solutions next year. And so that would mean that data engineers will now need to build new data connections, new data pipelines against data sources they haven't connected to so far. And so using AI for that, for example, could be really an accelerator for them. That's actually something that we invested in quite a bit in Boomi. We built what we call a data connector agent. And all you need to do as a data engineer, instead of sifting through API documentations and coding against different pagination settings and defining how data was going to be loaded to the target, and then applying on top of that the whole framework to monitor the solution, you can now use our data connector agent to just generate a connector for you. All you need to do is just copy paste the API documentation URL, and then the data connector agent goes through that, read the settings, provides the connection settings for you. You can of course modify it to your own liking if you need to, but otherwise you can just keep on going and get your pipelines up and running in just a few minutes. And then that same examples can be applied to other steps in the data pipe building process, and of course in the way that we can also monitor it and define the quality of it. So there's lots of opportunities in that process to introduce AI. I'm personally excited about being able to take that data connector agent I just mentioned to the next level, and being able to not just build a connection very, very quickly, but also maintain data pipelines automatically with AI. So whenever your source API changed or your schema drifted, being able to automatically handle that with AI, I think that's going to be a really exciting advancement that AI can bring to help us accelerate as data engineers. And I'm looking forward to see how organizations are using that.
And so as you continue to invest in either the work that you're doing at Boomi or the work that you're doing with customers and keeping abreast of the ecosystem, what are some of the predictions or trends that you have for the ways that AI is going to continue impacting the systems and teams that are responsible for data?
Yeah, I think data teams have been traditionally focused on building data pipelines and the infrastructure to support analytics. And in the past year, even before the rise of AI, I think they realized that they need to really deliver more ROI with data. And so they started getting closer to the concept of activating data. It mostly took the form and shape of what's called reverse ETL, how we can push data that we enrich in the warehouse back into application systems and processes. But it always remains somewhat siloed or limited with specific use cases. And again, as I mentioned earlier, I think most of the business process automation was happening by other teams, by the application integration team that sits under IT, but is not really part of the data team. And so I think what will happen now, one of the trends that we're seeing is that because the AI pipeline development will naturally fall under the responsibility of the data team, but the knowledge and the understanding of the business process automation is mostly sitting with the IT integration team. I think what we'll start to see is more and more convergence around those two teams kind of coming together. We've seen a lot of convergence around tooling, and I think now we'll see that around the way the IT organization is structured, bringing those two teams together and finding the higher value use cases where data can be activated. So I think that's going to be one significant trend. And the other one, we've touched upon that a little bit earlier, is the fact that agents are going to be spread in the business in a very unorganized fashion necessarily. And they will all carry a lot of value. So it's going to be a sprawl of AI agents being built into the business. And I think we'll see more and more tooling and solutions that they will help you govern and manage those AI agents, similar to the way we have toolings to manage our data. So these are two trends that, at least from a Boomi perspective, we've seen quite a bit, and we're investing in from a solution perspective accordingly.
Are there any other aspects of the survey details and the insights that you gained from that, or this overall space of data preparedness for AI that we didn't discuss yet that you'd like to cover before we close out the show?
I think we covered a lot. I think eventually one may think, the challenges are the same challenges we've always had around data management. And maybe that's the kind of the biggest takeaway of this whole discussion. Yes, we've always faced similar data management challenges and try to solve them to the best of our abilities. But I think now we realize that AI would just expose and scale those issues where we have bad data in a way that's going to be so much more impactful for the business. And so that is why we really need to get ahead of that as quickly as we can. Because of that black box, we need to make sure we control what we can control and then deploy it responsibly with the right tracking and monitoring behind it. So I said that's the kind of the biggest takeaway. Workloads are going to expand for data teams, and using AI to facilitate that as much as possible is going to be, I think, the only way out, because data teams are probably not going to expand much, if anything, shrink. And so they'll have to be really smart about the way they leverage AI toolings to be able to serve those AI solutions.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh, wow. That's a good question. I think data teams have been traditionally focused on building data pipelines or trying to deliver data as quickly as possible in the most efficient way. And what we've seen in the past few, maybe months, even a year or two, is we're entering an era of consolidation. And I think that's happening because data teams realize that finding the next best option to do a specific task that introduce so much more complexity into their overall platform. And so they're now pivoting back to a consolidated kind of motion, and let's have a platform that can do more. Maybe it's not necessarily covering all the areas of the data pipeline to the best possible solution, but it's at least giving me the option to move forward without having to maintain too much processes behind it or to kind of be buried in too much complexity. So I think as we continue to see that consolidation, what we'll need to watch for, and these I think the tools that will be kind of emerging as the winning tools, is the tools that are able to offer users that ease of use that they were able to gain with kind of point solution that were very good about something specific, but at the same time still maintaining the ability to understand what the tool is doing, especially when AI introduces such a big blind spot or a black box for us in many scenarios. At least understanding what we're doing on the data engineering side is going to be critical. And so getting that full transparency with that ease of use, that's something that not a lot of tools out there are able to manage.
Thank you for listening.
And so I think this will
Don't forget to check out our other shows.
The
Data Engineering Podcast covers the latest on modern data management, and podcast.net covers the Python language, its community, and
let's code it all
ways
ourselves,
it's being
which is usually not
Visit
the
the
right
site to
solution.
subscribe to the show.
Yeah,
sign
find
up
the
for the
balance
mailing
between
list,
ease
and
of
read
use
the
and
show
control
notes.
is
And if you've learned something or tried out a project from the show,
thank you
then tell
very
us
much
about
for
it.
taking the time
Email
today
hosts
to
at
join me and share the
AIengineeringpodcast.com with your
research
story.
that you and your team have done and some of the insights that you've pulled out of that. It's definitely a very interesting and necessary place to be focusing on and helping organizations come to grips with what they need to be doing looking forward, because the whole world is changing, whether we like it or not. So thank you for helping folks get a little bit ahead of that, and I hope you enjoy the rest of your day.
Likewise, thank you. I enjoyed that conversation. Thank you.